for this session, we will have opportunities to listen to talk provided by Professor Kyu Min Chao from Coventry University and Professor Do Sam Hwang from South Korea. So first, I would like to introduce Professor Kyu Min Chao. Professor Kyu Min Chao, he come from Coventry University, and by the way, you know that we have Nguyễn Tất Thành University and Coventry University have very good joint degree program between the two universities with very good, results. So, Professor Chao got his Master of Science and PhD degrees from Sunderland University in 1993 and 1997 respectively. And after that, he worked for the Engineering Design Center in Newcastle upon Tyne University as a research associate fellow for 3 years before he finally joined Coventry University, a senior lecturer in the year 2000. And after that, he spent 3 years working for the British Telecom Research Lab as short-term research fellow. And his research interests includes the areas of intelligent agent, service-oriented computing, cloud computing, and big data, etc., as well as the applications such as energy efficiency management and green manufacturing. He has over 150 refereed publications in books, in journals, in conference proceedings. He also the one who founded and is the managing editor for the Springer Journal, service-oriented computing and application. And more importantly, he sits on a number of editorial boards for a number of international journals. And he served a number of international conferences by taking different responsibilities as general chairs, as program chairs, and as track chairs. Please join me in welcoming Professor Kyu Min Chao from Coventry University to deliver his paper on cyber physical system for future higher education. Please.
First of all, thank you very much for Section Chair, very kind introduction. And it's my pleasure and honor to be here and to share my humble views on University 4.0. And today, the focus will be from different point of view, slightly different. Anyway, it's from cyber physical systems, more from engineering point of view to get the whole thing really. So this is the outline of today's talk, really. I will get started with a brief introduction about the higher education sectors in the UK, and to set the scene or give it a context, why University 4.0 becomes so important to the UK. And after that, I presume there's some people probably still confused what cyber physical system is. So I just give a brief introduction, clarify what I think, what it means. And of course, I think we're going to key back to the most important part. It's the cyber physical system in higher education. How we apply the cyber physical systems to improve the higher education in terms of teaching, administrations, even research. And in the end, okay, or the last part really, I will spend some time to talk about a CLAM project, which is funded by the European Union. I've been working with a number of researchers from different universities within the EU on e-learning, and so share some experience with you guys. And of course, in the end, I will just give a brief summary of the talk and draw a brief conclusion as well. Okay, right. Let's start with the higher education in the UK. Okay, and it depends on how you look at the how you define the higher education in the UK. Roughly, we have 130 universities, and from the established time, okay, we can roughly divide into 4 tiers. The first tier, okay, is ancient, means 17th century, like Oxford University, or 19th century, like Edinburgh or Glasgow. And like Durham. And then we have a Red Brick University. That means was established during the Victoria time, like Birmingham University, Leeds, Sheffield, and Liverpool universities, etc. And in 60s, okay, there's a large number of universities been established. For example, Newcastle, Keele University, York, Warwick, and Bath University as well. So there's 60 universities. And the last wave, okay, is post-92, and that including Oxford Brookes, Coventry University, Portsmouth, and even after 2000, we still have a few universities have been established. So it's quite a large number of universities we have. Okay, right. So before 1997, okay, it's a free education for the UK students to attend the university to receive the degree. Until 1998, the tuition fee was first introduced, and that will be equivalent, and that will be received £1,000. You have to pay £1,000 to it. Not equivalent to roughly $1,300 a year. Okay, in 2006, okay, they increased £2,000. And the big change, okay, in 2015 to £9,000. Okay, right. And of course, the overseas students, which is non-EU students, or the EU students, okay, we consider as home students, so they pay exactly the same fee as home students. The overseas students here we're talking about is non-EU students, okay, so we have different fee schemes. Normally they are far more expensive, but nowhere near like the United States, okay, so it's still far more cheaper. Okay, right, so because the government fund the research, higher education, so the government have a limited funding, okay, so they cut the number every university that they can take in. In other words, okay, Oxford, Cambridge, they can take certain number of students every year. They cannot exceed number. If you exceed number, we get penalty by the government. So this apply to all the universities in the UK. Until 2015, they leave the cap because this £9,000 basically can cover the cost of the university to run. So in reality, okay, since 2015, all the universities, even we still think they are public universities, but in real term, it's a private universities. Okay, so there's no cap. There's no cap on the number of students you can take. So Oxford, Cambridge, they can take as many students as they like, as they think is appropriate. They are capable of doing it. Okay, Coventry can do the same thing as well. Manchester can do the same thing as well. So become a stiff competition between these universities. So some universities are expanding, some universities are shrinking, close the campus, close the courses since 2015. Okay, where would we get the money? Okay, the money, we have two chunks of money, okay, we can get from the government. One, okay, is called Research Exercise Framework. This decides roughly £1 million a year, how the UK Research Council distribute the money to all the universities. Our UK government, okay, don't have selected universities. So okay, like the previous talk, selecting university, then we get special funding to it, not block funding to it. And we don't do that. We based on your research output. and then based on the output, then you distribute the money. Okay, and then the last exercise was 2014, and then the next exercise will be 2021. So this and then depends on your research result and how much you're going to get out of this £1 million a year, the proportion of it. Okay, right. Earlier I mentioned about the tuition fee. Okay, we start to increase the tuition fee to £9,000, but also based on the inflation rate. And the UK government tried to relax the tuition fee for the university. In the moment, it's the UK government put a cap on it, so you can't increase over the inflation rate. So now what they're going to do? Okay, they come up with this called Teaching Excellence framework. So that assess the university teaching quality or the student experience. Or there's some number of criteria anyway, and to say okay, then give us 3 different categories: gold, silver, or brown. If you get a gold, then you can increase your tuition fee by X amount. If you're brown, well, you cannot. Okay, so that it's that will again have a significant impact on the income for the university. So really. Okay, and the other important indication, okay, for the university is the National Student Satisfaction Survey, which have a significant impact on the teaching excellency framework result as well. Later on, I will talk about a number of other rankings, which could also have some impact on the student intake or the student income or university income. Okay, right. So as I mentioned earlier, okay, there's no cap on the university the number of students it can take. So it becomes very stiff, okay. And then the students, okay, the way they look at it, we have roughly 2.8 million students a year, really, to join the higher education sector. So a lot of students are confused with which university they should go to. So that normally they look into all these rankings, really, from the newspapers, or earlier, from this QS or this the THE, or different kind of rankings. Look at that, and one thing, okay, one thing doesn't matter what happened. Okay, one of important criteria is take the student experience into account, and not including like a completion rate. How the students satisfy your course, how many get employed within 6 months after you graduate. Either you get a job in a good company, or you go for the higher education, that means master's degree or PhD degrees. Okay, we have a number of rankings, okay, the Times, the Guardian, and the Higher Education Times, etc. Okay, they all, as previous speakers said, that they all based on different criteria, and even the same criteria also have different weightings. So they come up with all different list of top universities, really, in the UK. So unfortunately, okay, a university have to pay attention to all this ranking, doesn't matter what it is, because the students, this will have a big impact or influence on how the way the students choose which university or which course they want to go to. Okay, right, so university have been forced, really, got to be very agile, adaptive, and then got to make the staff very efficient. And the other important thing is you need to digitalize everything, really. Okay, right. So basically, I just give a broad overview. What's UK higher education sectors at the moment. And the next one I'm going to talk about is the CPS, Cyber Physical Systems. Okay, I think that this is a quite a famous picture, really. An elephant, a blind person touched the elephant. Depends on which part it touched. So come up with different ideas of what the elephant looks like. So I'm trying to tell you, okay, there's no consensus on the definition over this CPS, really. So different people given different views on it according to their own experiences, depends on their purpose really. Okay, right. The term, okay, is not really not new. It's 10 years old, really, at least. This is stuff from the NFS, really, in the United States, because the NFS, at the time, I think it was a chief scientist advisor to Clinton, will come up with this term, say, look, the United States government should start to fund these research directions. And then, funny enough, okay, at the time, the European Union really didn't pay too much attention to it. At the time, was more focused on this, because under the Framework 7, still focused on this embedded system, real-time system, rather than CPS, really. Okay, right, so what I'm trying to tell you, okay, the United States take a step ahead on this area. And, but what is a CPS, okay, and from their definition, okay, basically they think it's an engineering system that are built from and depends on the seamless integration of computational algorithms. So basically it's algorithm and the physical components is between the software and the hardware, really. So they will think, okay, the advance in the CPS will be able to push the capability, adaptability, and scalability, and resistance, safety, security, and usability. And now we're far exceeded simple embedded system today. So that's what I'm saying, the European Union was a bit behind in this particular area. The important bit, okay, I like the last statement in this slide. The CPS technology will transform the way people interact with engineering systems, just as like internet has transformed the way people interact with information. The internet has changed the way how we access to information, how we use the information. And then they believe CPS will play the same role like internet. Okay, right, here's an example, okay, of physical assets, such as device, sensors, and that interact with machines or human in the real world. As you can see, I want to make sure. Okay, so this is the physical world here. So we have a PC and everything. Okay, then we have a mirror digital world, which is a cyber twin to the physical world. So exactly the same thing. Okay, it's just mapped to that, but this one a future one, virtual one. Okay, right. So basically the virtual one receives the data from the sensors from the physical one and process it, become information for the decision maker to decide if there's any further action need to take. Okay, once you make any once you pass the message or pass the control to instruction to the physical devices, they will change the behavior, change the state, which will back to the virtual world again. We provide with new data, new information, and then the decision maker system can based on that to reason over that. Can based on that to reason over that, and to make recommendations. So basically, it's a loop. So CPS basically it's a smart system that co-engineer interacting network of physical and computational components, and this system will provide a foundation of our critical infrastructure, form the basis of emerging and future smart devices, and that importantly is will improve our quality of life really, in many ways. And basically, the CPS involves three disciplines, really. The computational software, control over the machines or physical and systems. The systems sit between the communication and control. And then the communication between the computation system and physical is through this cyber system, really. And the common components they have is the information. So this is how the three disciplines interact and how they feed that back to each other. Okay, right, so now we come down, sorry, probably the quality of the pictures, okay, I might not be able to read the small print, but basically I'll just quickly go through. If you look into this CPS, okay, instead of three big blocks, three big components, we can break it down to 5 different layers, that help you to understand how it works or what its potential is. Okay, right. So I think these two dimensions we can look into is from function point of view and attribute point of view. Okay, the bottom layer is a smart connection layer label, and then the one label up is data to information conversion label, and then further up is a cyber label, and further up is connection label, and then the last one is on the top, which is a configuration label. Okay, the smart label here, remember this is more for engineering. So imagine that it's a factory, so you want to turn into a smart factory. So that is the sense you want to do. So what you want to really have a plug and you allow the to allow all these sensors, all these devices can plug and play. Okay, and then they can talk to each other through the communication lines. And then they have a well-established sensor network. So for the data, okay, data to information, and they should have some smart analytic software for components to analyze the components or the machine health. And they also be able to collect different data and then to mark that out among these multiple dimension data reading. And then they can do some predictions, for example, for the degradation or maybe some performance. In the cyber layer, okay, basically it's the twin model for the components and the machines. So the time machine for variation identification and the memories. So basically they can use the information regret or the simulation model to simulate what happened. Okay, the connection label, okay, so basically it's try to integrate the simulation and synthesis. So with hardware and software, with a bit of AI in it, and then try to find out exactly what it means or what's going to happen. And then the other beauty of you can, the physical world, okay, will turn into virtual world, and then that can be visualized by the user in the remote site. And then all this information basically, and the system, they allow human beings, okay, or decision makers to collaborate to diagnosis and jointly make decisions based on what the simulation, based on the information they got. On the top, okay, and on the top, hopefully the machine will do self-configuration for resistance and will self-adjust for variations and self-optimize for disturbance. So in other words, the machine will automatically do the configuration and to meet what the user wants or what the system needs. So this is the CPS for the Industry 4.0 really. Okay, now we're going to translate that into this 5C architecture to higher education. So let's start with a smart connection layer. Okay, again we need sensors. Okay, the smart connection layer is, in fact, the connection not only just connection, but also provide the input to the data information conversion. So, like the sensor. Okay, the sensor itself is not only just installed; it's collecting data and then send it to the computer systems so they can process it. So in this case, okay, we have a sensors network and quiz, which is an in-class test and exercise. So or the student attendance. So we can get the information, the data through this layer and then feed that back to the system. So then in the data information conversion layer, then we can say, okay, the student's attendance statistics, the course performance, and the cyber layer, cyber label here, we can predict students' progress and progressions. And then connection layer basically is looking to the coordination between the classes and modules and the collaboration between the lecturers and management teams. On the top, with the configuration label, okay, based on this information, the system hopefully will transform the learning environment by itself. And then by providing a set of flexible teaching methods, so it depends on the students' needs, and then the course objective outcomes, and then we can automatically adjust. So the next few slides really, just give you some in fact, I cover most of the points, really. I just give you some more information, really. So, for example, okay, the networks and sensors, okay, so that is the first thing you need to do to have a CPS in higher education. The network here, okay, very simple, okay, for example, not the internet what we got only, okay, the network here, not including the software you use. So, for example, for computer science, okay, or engineering courses, they use a lot of software packages, like a MATLAB or like any CAD systems or whatever it is, or simulation tools. Okay, right, so you might find out one thing, okay, you only can use it in the university or particular computer or particular lab. Okay, but here you can use anywhere. The idea is you should be able to use anywhere, anytime, and depends on the user ID and the IP address. And the sensor here, okay, and later I will give you an example, okay, how the sensor can work in the class. And the quiz become important, okay. And the quiz here, because we want to know what students, what sort of progress they made, or how much they have learned from the class. And so often we do in-class test or some exercise. And then within this one, okay, then we probably give them some multiple choice, so they can choose. They can choose different answers. Then we easy to mark them. Or sometimes it's difficult, okay, because some questions will become like open questions, so they come up with different answers, But the key thing here, okay, because the key thing here, okay, and these are very important input data for the information system really to process, to find out what sort of understanding level for the students really. And the other one, okay, is student attendance. So the students, okay, nowadays they have an ID card, student ID card. So if you have this RFID readers in the classroom, and then if you link with timetabling software packages. So in other words, each classroom has been allocated by the software systems to certain modules at a particular time. And then you also link with the students' registrations. And so when the student come in, with their ID, student card with RFID, and then the system should automatically pick it up whether students attend the class or not. Okay, once we got that information, okay, then the system can start to transform all this data into information, really. The first one, you can see the student attendance, can produce the student attendance statistical information. So who is there, who is not, without the lecturer going there to check, system automatically pick it up. And then from this information, you can see, how the course of performance, in other words, you have an in-class test, then you can see what's the progress the student made, and the overall course performance, really, students, how they respond to all these teaching methods, and the module performance. And at the same time, you can find the classroom allocation and the lab arrangement. So whether this classroom have been allocated efficiently or not, or how many empty rooms during the class. And then we can see the staff workload as well. In the cyber level, okay, we got all this information that depends on individual students. Then we can put all different modules of that particular student together. So to see what sort of progress this students made, or is likely to progress to the next level or not. In other words, from first year to second year, are you going to pass all the modules or not? And then through attendance, we can see the students how much they engaged with them. And then we can predict, if they attend and then do well, likely the student might satisfy with the module, with the course. So we can predict that. If not, then we can do something about it. Then at the same time, we can see the lecturer performance and to see if the students feedback nicely, and so the lecturer might be able to continue the work. If not, they might have to adjust a little bit on that. And of course, we have a lot of online learning and modules and then materials, and might be able to not allow the students to look into it and do the exercise to learn anytime. Then, because the beauty of online learning, okay, the students, if they use it, if your student look into all these materials or do the exercise, and the system automatically will record it. So we can close monitor the students' performance really, or how much they engage. And because all this information, okay, and I don't know you guys, okay, I mean in the UK, okay, there's 2 time slots most lecturers wouldn't like to teach. One is a Friday afternoon. The other one is a Monday morning. For the Friday afternoon, okay, the culture is slightly different over there, okay. A lot of people like to go to the pub on Friday afternoon or evening. So they won't attend the class. They just, they will skip the class. They want to go to the pub. And they have been drinking, since Friday, Saturday, and Sunday, okay. So on Monday, okay, they couldn't wake up. So likely they're not going to turn up on the Monday morning class. So there's 2 time slots. We don't like it at all. I mean, most lecturers wouldn't like it to teach, really, because of the poor attendance rate. So anyway, so this kind of information, then we can, do the scheduling, make sure the class or the module has been timetable appropriately, really. Okay, right. Now after that we get our information, then we can move to another layer connection. Okay, so we can see the coordinates between classes and modules. So this course is, will it fit into the, when really work nicely with all these modules or not? Where this module really support the need of these courses or classes. Then we can see the collaboration between the lecturers and management teams, how well they work together. So all this information, the university can define the new strategy. For example, how many students we can recruit if we still got a lot of spare capacity to take in, or maybe we need more lecturers to deliver the courses, or we maybe need a new building. So from all this information, and maybe we have to change certain courses, learning outcome, or maybe we have to adjust some learning objective as well for the degree or for the modules. So this will give us information really to see whether new modules are needed or not. Whether do we need the new learning methods or not. Whether the existing methods is it okay or not. Okay, the last bit, okay, was the configuration. So all that information, okay, then we can start transform the learning environment, either through online, 24 hours, with the flexible credit systems, all that kind of stuff. So, and flexible teaching methods, flexible methods, adaptive learning, social media, interactive. So it depends on all these. The system automatically will do the recommendations for that. And the other important thing is personalized student experiences. So all this information, then you can start to personalize what students need and then give them appropriate courses or teaching materials. It's not working. I think the computer gets too excited with this slide, so it freezes. Oh gosh, the whole thing freezes now. So basically, what I just say, okay, because it's, Industry 4.0, okay, we have this 5C, and then to support the how to automate everything really. So from the connections, network connections, get the data, central information to process. Yeah, okay. Central information to process it. Information to process, get some statistical information. After that, then you can use the simulation tools in the cyber world to find out what would happen if you do A. If you do A, what's the consequence going to be? If consequence A happens, what sort of action we should take? So you can simulate all different things. So give you, for the decision makers, they can based on that to assess what next action should take. And then the topic is the cognition. Okay, so basically, because you've done the simulation now, so you know what sort of decision you should make. So start to implement it, start to introduce new measures, maybe manually or automatically. And the last bit, cell configuration, the system automatically, if we talk about everything is digitalize it, will automatically do all the adjustment. That's ideal, okay. Later we'll now we talk about the challenge, okay. The idea, the one I put down, okay, it's quite ideal situation, okay. Not the idea what I put up is quite ideal situation, really. But I think that most people, most university at the moment, only, like a lot of companies as well, they are still struggling with digitalization. The reason I say that, okay, you mentioned that marking. I think most lecturers at the moment still marking, through your pens and pencils, and then you got to go through the scripts one by one. But can we do automatically? For the quiz, multiple choice questions is easier, but for the open questions, answers might be difficult. Okay, so we are setting up a new program with a Chinese university. Okay, and try to automatically assess the open questions in the exam. And the reason we can do that now is possible now because the natural language processing is far more powerful than before now. It's more advanced. So this was impossible, but now it become more or less possible now. Okay, I'm just giving an example like that one. Okay, and then even a lot of university, okay, already install a number of different supporting softwares. Okay, I'm just later I'll give you some example like Moodles, and the previous speaker was saying SAP, all this kind of stuff. But the big problem we got now, these are heterogeneous software. They are not really integrated, really. And again, even within the university, okay, and even we have a network. We have a wireless, Wi-Fi, all that kind of stuff. But because a lot of engineering or specialized tools, they require some special communication protocol or interfaces. So they still cannot communicate really, talk to each other. And then the other one is education software tools. Okay, and students normally have the access to different software tools during their degrees. At the moment, okay, most of the university only allow the student to use them in certain lab or in a university. So can we allow them to use anywhere without these kind of restrictions, anytime? Okay, of course, we still have a big problem with different types and or different pieces of hardware system as well. So they cannot talk to each other really. That's another issue. So now I'm going to talk about the Coventry. Okay, we provide a number of supporting tools. Okay, and to give some, we have a Moodle. So probably a lot of universities use Moodle. Mainly is for teaching, management really. So you can find a slide, managing the students. Then have a Sonic. Sonic is more to do with documents. And then for the human resource management, we have a CoCrease. Then if you have a lot of papers, or we have to manage all these publications, then we have a Pure. And if you have any IT problems, we have this log-me-in systems. So allow you to report your problems, and then the system, any problems will be recorded, will be solved, and traceable through this stuff. And then we have this ethic management system. So in the UK, okay, and all the projects got to be evaluated, really to see whether it's ethical or not. Any work you're doing. So we need to go through this ethical management system. And for the classroom, we have a timetabling. We have a timetabling system to allow you to book the classroom, or for the whole year, or for a particular time for a meeting. Okay, right. So even we have so many softwares. Okay, even we use different. We have so many different softwares to deal with different things, but we still have problem with the communication or integration between all these softwares. Okay, right. And simple example. Okay, like printer. Okay, and I don't know here. Okay, and if a student have one document, okay, or some coursework need to print, assignment need to print, so they only can collect this the hard copies from certain printer, or they can only print out from certain printers. But can they print out anywhere they like, in the campus or outside campus? And here again, okay, can your home PC access to the university software? Since the university already bought the software, from the vendors, so they should look into the user ID rather than the PC IP or the IP address. Okay, right. So this is a simple issue like this. Okay, attendance management. Okay, the student got, I mentioned earlier. Okay, the student normally got your student card, and the student card. Okay, normally what we got is the RFID, and each classroom have an RFID reader. So the student, before they attend the class, okay, or they just go into the class, they have to swipe or just touch the reader. So the system automatically pick it up where the students attend the class or not, or is in the class or not. If a student didn't attend the class for the two consecutive times, for example, like this week and next week, the system automatically will pick up, and then will alert the module leader, will send an email to students. Okay, even we got all this, then we have this called Sonic course management system. Okay, this course management system basically have a list of modules. Okay, and for the courses the student must attend. So from this system, so we can see the overall student attendance rate for the module for the courses. And the Moodle, okay, basically for the lecture notes, for the quiz, for the in-class tests, everything we can implement here. I think Colorado University use one. There's another very popular system called Blackboard. And then the Moodle system, okay, the good thing about it, plagiarism always the big case, especially when you're writing an essay. It's a big problem for the university, really. So in the Moodle here, okay, we can use a tool called Turnitin to automatically detect where the students' coursework or assignments has been any suspicion of plagiarism. Okay, right. So I'm just giving an example. Okay, even we have two simple systems. Okay, the Moodle. Okay, as I mentioned earlier, they have a quiz, and then when you do the lecturer do the marking, they can put the marks in it. That's another thing. Okay, in the UK. Okay, which is slightly different from here, from probably more in the European countries, really. Or probably the United States, we cannot announce other students' marks or the result in front of the class. So basically, we only can inform the students for their mark. We cannot inform other people's mark to other. Sorry, we cannot inform the student mark to other students. Okay, right. So it become a problem now, and so the only way we can do it really is through this. The Moodle, okay, so basically our system automatically will announce that, will be able to see that really. Okay, right, so we have a Sonic system, okay, and which is in charge of this attendance, but there's no link between the Moodle and the Sonic system, so we cannot really find a correlation between if a student doing badly, so what would happen, and what happened is because of poor attendance or not. We have to do manually to pull two information systems together in order to do that. Okay, right. So basically, I just give you some overview. Okay, so we done quite a bit on this digitalization, but as I said earlier, there's a problem is integration, and a lot of digitalization haven't done yet. As I said earlier, I said like a marking, all kind of things. Okay, right. The last one. Okay, I'm going to quickly go through. Okay, I'm aware I'm running out of time. Okay, it's a cloud service for e-learning, so I'm going to skip quite a bit of slide. So basically, this is a EU-funded project. Okay, involve 6 countries, 7 institutes within the EU, and so ideally, okay, it's what we try to do here, and because like a CNC machine, okay, robot arms, robots, they are very expensive, okay, they are very specialized. And then each university can only have a very limited number of all this equipment. And then a class in the UK normally roughly have about 20 to 30. So unlikely we have a 20 or 30 machines can be used at the same time. So within this project, okay, what we try to do here, try to pull all the European, some institute together. So if you have you have a 3 CNC machine, I have a 2, so can we pull it together as a virtual pool? So this 30 students can use this machine together. So that's the idea. And so basically this here, what we try to do here is try to set up some remote lab in different countries. And then the learner, okay, can access such equipment and then support there some practical learning, especially in mechatronics, this area. Okay, mechatronics basically it's a multiple disciplines combining electronic, computer science, and electronics. So not only just lack of equipment to do it, but sometimes the instructor or lecturers also have some problem with resources and time management as well. So basically, we try to make all these idle or unused, all these CNC machine available and in the pool, so they can be shared among the users, among the different institutes. Okay, right. So basically, I'm not going to talk about this one, e-learning. There's 3 types of remote lab, okay, and how do we do it? Okay, you can use the batch. So basically, whole experiment defined in advance, an instruction set, and so the experiment can be run without any user interactions. And the other one is more interactive one, really. The user can be involved, be able to change some parameters. And the last one is monitoring. So basically, they use the sensor to collect the data, and then the user only simply can monitor the status of the machines rather than you can control anything really or carry out any interaction with them. Okay, right, the virtual lab. Okay, so basically there are 3 types of virtual lab: recreation one and simulation one, really. And different institutes have worked different way on, to support different things, to support this e-learning. And the remote lab, okay, and what the claim can do, okay, what we try to do here, we try to have a real device connect to the software control, so the student can really can use the software to control the real device like CNC or robot arms, and then we hope there's some community which is in the same area can contribute to their knowledge. So we set up expert channels, community channels, so they can, like a Facebook, they can share some experiences. If you have any questions, then you can ask this expert through this social medias, and hopefully the experts can answer the questions. So we try to adopt we try to resolve this problem by adopting the cloud technology, really. I'm not going to repeat this log here. Okay, you can see this is some properties here. And so basically, the system we design is on demand, it's self-services. So basically, we can deliver e-learning resource to the teacher and then a learner based on their demands, because we can connect to different number of machines and type of machines, and depends on what you need, really. And then it's a broad network access, because we make it available over the internet, so you can access it anytime, anywhere, by any device as well. It's a resource pooling, okay, so we pull in different, not only just machines, but also learners and trainers together as well. So they can exchange the hardware resources, but also exchange their knowledge and experiences. And then because the whole system, okay, it's based on this cloud concept, so it's rapid elasticity, okay, so the machine can be increased by we need register a few more machines. You can include more machines when you do registrations. And then The major service, okay, and the cloud mentioned, okay, because you got to pay for it. But in our case, it's free services because it's funded by the EU, so we cannot charge. Okay, right, so I'm not going into detail about this overall. Okay, so basically three layers here: infrastructure, platforms, and applications. So basically this diagram here show you the components or supporting components of what we have in the system, and then that compare with the service model in the cloud. I'm going to skip this bit here because this it basically try to say, look, our system is quite unique because this is not haven't been done before, and we compare with other existing architecture or methods. Okay, right. So basically, this is give you an overview, okay, and what it will look like. So basically, we have a trainer and a learner here. So this is an end user, could be anywhere in the world, and then they can have this server here, okay, and then they have a remote PC connect to all these microcontroller control linked with the actual CNC machines or robot arms or robots. So here also have a rapid codes builder. Okay, so basically it's like a Moodle. You can easily to pull all these slides and courses programs together. And then we have a community expert forum, so you can ask questions. So here we basically is to show you the just give it over a picture really. And this is the web page, and this is some simple slides about this about the engine works. And this is a timetable that you can book the time, how many machines you want. And this is actual, you can control it, and in this case, it's through a motor. And this is on the side, so you can control the CNC machines and some electronic components or equipment. Okay, right, so the next few slides really, just quickly go through, okay, because it just gives you some ideas about, we send out questionnaire over 1,000 students or participants and find out what do they think about the system. So this is just some of the questions we ask. And we ask also how helpful is the tool, the CLAM project, and how easy we can use, and how this activity can help can generate the interest for the students. And we are talking about the style. Okay, right. So basically, this is a CLAM project really. So basically, it's a population problem really, and so this is tailored for gathering this heterogeneous distributed mechatronic device in a common pool for the learner to use. Okay, right. So the conclusion here. Okay, I think the Industry 4.0 and Education 4.0 share common characteristic. Okay, automation and quick feedback and reactions, big data analytics support decision making, and to have an agile environment and goal-oriented management really. But the first thing we need to do really is to digitalize. We haven't done the digitalization, similar to Industry 4.0 really. And then after that, then we need to do integration before we can go further up really. Even with the bits piece in the information layer, cyber layer, and connection layer or the configuration layer, but not really talking about full automation. Still far away really. And of course, we need to explore more on AI and machine learning, to automate everything really, and to give a real and useful feedback. Okay, sorry, I've been a bit long over the time, so thank you very much for listening.
Thank you, Professor Chang. Actually, we are a bit behind of schedule, so may I suggest that we would have one comment or one maybe question from the floor, and then we will proceed with the second speaker for my session. Could you please? We would like to invite one question from the floor. You have any question, please? So I think maybe after a while we will have questions for you. Thank you.
Okay, thank you.
Professor Chow, thank you for your very interesting, insightful, and especially very detailed explanation on how can we apply cyber physical system in higher education. Thank you, Professor Chow. Yeah. Next, I would like to call upon Professor Do Sam Hwang. Briefly, okay, I will be short. Yeah. Okay. So Professor Hwang comes from Yunnan University from South Korea. He is a full professor for the Department of Computer Engineering at Yunnan University. His scientific interests include natural language processing, ontology, knowledge engineering, information retrieval, and machine translation. Professor Hwang served as the head of Yunnan University Computer Engineering Department for 5 years from 2005 and 2009. He has also held position and as invited professor for Korea Advanced Institute of Science Technology and principal researcher for Korea Institute of Science and Technology.
Professor,
so okay, patient, yeah. You have anything to read. Anyway, he also has been chairing several international conferences, serving as a member of a number of Korean high-profile projects and so on. In recognition of his great commitment and contribution to the field of study, Professor Hwang has been honored as a distinguished researcher for Korean Institute of Science and Technology by Korean Ministry of Science and Technology, and awarded a prize for good conduct from Kung Hee High School in 1973. And thank you. I would like to invite you just to deliver your presentation on education 4.0, future education for the fourth industrial revolution. Please, Professor Hwang.
Thank you, Session Chair, Professor Nguyen, for the introduction. Good afternoon, ladies and gentlemen. My name is Do Sam from Korea. To begin, I'd like to express my deep, sincere gratitude. Thank you. To Professor Nguyen. There are so many Professor Nguyen. It's so convenient. Especially, I'd like to give my deep thanks to Professor Ngoc-Thang Nguyen and NTTU persons for inviting me to this wonderful conference. My topic is education. I deleted the future. Education for the fourth industrial revolution. As you know, the fourth industrial revolution is coming to us. Maybe we have already lived in the age of fourth industrial revolution. Of course, there are counter-arguments to this claim. For example, some experts, even the definition of the fourth industrial revolution has not been established. But the fourth industrial revolution is long, so I will call this only 4IR from now on. It's a hot issue in Korea too. Okay? So we encounter this word 4IR every day, maybe more than 5 times. So the revolution will open a software-oriented, centered intelligence and information society. According to the Future of Jobs, published by World Economic Forum, called simply Davos Forum, published by 7 million jobs will disappear, while about 2 million jobs will be created by 2020. Believe it or not, already published by the qualified authorities. And the famous futurologist Thomas Frey predicts 47% of jobs will be lost due to AI or robots. It may not be a revolution, but it is obvious the new changes have already occurred and coming to us in the industries in the world. I will show the 3 examples. As you know, most experts thought machine could never defeat human at Go game, an ancient board game. But last year, AlphaGo defeated Sedoli, Korean player, one of the world-class players, last year, March 2016. And in this year, AlphaGo defeated Koze, the Chinese, one of the top-ranked player, in May in 2017. The second example is, in 2017, US IT companies occupied the top 5 companies of global companies in the world based on the brand value. What you can see is all the top 5 company is IT company. Okay? Google, Apple, Amazon, AT&T, as you know, Microsoft. The last example is Korea company invested $20 billion. Oh, sorry. Sorry, thank you. Invested $20 billion to the semiconductor fields last year, but only 900 workers have been employed annually. For example, you know, Samsung Electronic Company invested $13 billion last year, but additionally, only 650 workers were hired last year. What do you have to do when the new age, the surge of new age is approaching us? It is clear, as you know, industries are important for human and country development. New technologies can create new industries, and new industries transform country and can make new country. These new technologies can be developed by new education. Then, what are the main technologies for the age of 4IR? As you know, these includes robots and drone, big data, and AI, AR/VR, self-driving cars, IoT, 3D printers, NLP. I'm sorry, missed Professor Nguyen, missed nanotechnology also can be included. So you can see here is software is core technology for all these technologies. So software education, so called simply coding, is already being taught beginning in the low levels of schooling in several developed countries, US and Great Britain, and so on. In Korea, software course has been chosen as essential subjects in elementary school, junior and high school, starting in 2018. So, I suggest you software education from an early age as part of education for the future, for IR. Of course, there are pros and cons to teaching software from an early age, but it is very essential and beneficial to the age of 4IR. New education methodology and systems and tools have already introduced and are operating by several developed countries and universities. Professor Vossen have already introduced with very good examples, MOOC, adaptive learning, and blended learning, classroom with SNS and digital devices. I will skip this, and I do not focus on this subject today, so I skip. My university has an e-learning center where professors and students make their lecture materials and contents with these systems. So they can operate the materials developed by the e-learning systems, as I have introduced. So Professor Nguyen thankfully visited my e-learning center. And this is the picture from the visit, where, as you know, Professor Nguyen is very sincere and very diligent and active, came to my university and see the system with me. So I respect Professor Nguyen. It takes about only 10 minutes for young students to learn how to make the lecture materials. Okay? Of course, it takes about 30 minutes for me and Professor Nguyen too. Okay? So I agree with Professor Vossen's early recommendation, okay, to hire younger instructors. I completely agree with you. As an encourage policy, during the introduction steps of internet lectures, additional salaries have given to the professors conducting the internet lectures, and special scores, assessment scores have given to the professor's achievement. I did not join the policy, the internet lectures. Anyway, education administration should be also operated systematically. So, almost all of administration of my university is operated by a URP system, Universal Resource Planning System. It is one of screenshot of URP. So there are many kinds of administration is operated. For example, undergraduate and graduate, general administration, and R&D and operated organizations. As so many, for example, of undergraduate, there are register, class, grade, scholarship, graduation students, and employment, and so on. Okay, there are so many functions, each administration and management, so I skip. I only explain the rule book. Okay? The attendance of students was checked automatically by sensors equipped with every classrooms, and the log linked to the grade system, so calculated scores automatically. And more you can, and as well as students can use by the PC, computers, or smartphone applications. This is a lecture supporting system of my university. There are notice and Q&A bulletins, and professors can upload their lecture materials, and students can download the lecture materials, of course, and students can upload their reports. And there are lecture introduction and schedule, of course, and professors can search the students' information, okay, and can communicate it with students by message system, email, and smartphone message was linked to this. But although educational methodology and system tools are so good, if you do not use them in your circumstances appropriately, they become useless, okay, as you know. So education must adapt as necessary. So I think Vietnam is very similar to Korea. So I surveyed, okay, especially in terms of, in terms of education and economic growth, not, it is my monopoly. So this graph shows the number of universities and students according to economic growth in Korea. Okay? This blue line is Korean GDP. Okay? In 2015, Korean GDP was $27,000. Okay? It is more than 11 times the number in 1985. And this yellow line is for number of universities. That number reached to 433. Okay? It's about twice than 1985. Okay? And the number of students is green line. There were 3.6 million students in 2015. Okay? It's about 3 times the number in 1985. Next graph is a Vietnamese graph. I surveyed. Same. This is blue line GDP. In 2015, GDP is about $21,000. It is almost 7 times greater than 1995. Okay? And the number of universities, that number reached to 445. Okay? It's about 7 times. And the number of students there were 2.1 million students in 2015. Okay? It's about 4 times the number in 1995. Okay? So this graph shows the 2 countries overlap. Okay? The upper blue line represents Korea, and the bottom line shows the Vietnamese graph. Okay? So what you have to see is overall the pattern of the graphs are so similar. Of course, the number of the university has increased rapidly since 2004 in Vietnamese case. It's very similar. So before telling what we have to educate, I'd like to tell about what is education. That is the definition of education. I'm very happy. You also got the very good present, book and badge. There were very many good words about education by the very famous people, Steve Jobs and Benjamin Franklin and Mandela Nelson, and so on. It's very good. Okay. Of course, many scholars have defined the education from various aspects, especially in West. But I'd like to introduce one definition defined by Korean scholar. I like it. He defined education is a way to improve human life and make it affluent. It has its real meaning in raising humans righteously and in providing the elements that constitute our personalities. I like it. I think that is the definition of a truthful education. As you know, there are three elements to education. Students and teachers and books can be included facilities also. Based on these three factors, I represent education by functions. I have already introduced this mathematical model of education at an international conference, ACII 2015. The general chair was Professor Nguyen. So I only explained conceptually, not theoretically in depth. Okay? I represented two functions. One is EVE, quantitative progress, and the other function is qualitative progress in education. And the entire education represented by the multiplying the two functions, quantitative and qualitative functions. The basic quantitative measure of education progress, EVE, the first function, is represented by three factors: student, teacher, and text. And each factor is represented by exponential function. So there are limitations to quantitative factors of educational progress. So as an example of improvement of the quantitative measure of education, EVE, I will show the case of Korea. This graph shows Korea has invested the budget, increased the budget of education and R&D budget since 2007. Okay? In 2007, the budget, education and the R&D budget combined were about $41 billion. It's about 17% total budget for Korea, and increased to $77 billion. It is about 19% of total budget of Korea. As the growing economic growth, Korean government and companies have supported universities in various ways. I'd like to tell you three types of supports. The first is Korean government supported universities, large-scale projects to cultivate students, such as BK means Brain Korea, and Link, CK, Creative Korea. Prime, very good name. WCU is a world-class university and software-oriented university. The second is Korean company have supported universities by opening customized education departments. It's each to their suited to each company. Korean major university, such as companies, as you know, Samsung, LG, SK, and NHN, called simply known to Naver, have joined in these projects with the agreement of universities. So these projects help students to adapt early, just after graduation. So they can use their knowledge and contents studied in courses, which is suited to each company's specialty. The last is contracted departments. A representative of them are semiconductor department open in Sungkyunkwan University, as there are software specialized department and big data and cyber national defense department. So students can be employed just after by the graduation by the contracted departments. These are national projects supported by the Korean government, but I think we don't have much time, so I'd like to skip this. As an example of the results by increased the EV, the quantitative measure of education, I'll show you the rank of Korean university. This graph shows the rank of the Korean three representative university, for example, SNU, Seoul National University, and KAIST and POSTECH. Okay, so since 2004, okay, the three universities tend to place or top 50 in the world. Okay? But let's look at the graph in detail. The three universities have been at the top 50 before 2014. Okay? But they could not break the strong world, the top 20 in the world. Okay? 20, only 24 is best. Okay? And more, after 2014, all of the three universities have fallen, okay, below top 50. Okay? So I think you can see there are the limitations in the progress of the quantitative education. The second factor is qualitative measure of education progress, EM. It is composed of, three factors. One is relationship and the spirit and time. Okay? So conceptually speaking, my MS medical model of education are represented by two functions, as I have already introduced. The first is quantitative measurement, EV, okay? And it is represented by the volume of the figure, okay? I defined. And second function is represented by color, the density of figure. Okay? And the education measured by the mass of the figure. Okay? So I show you already there are limitations in improving quantitative education. So we have to focus on improve the qualitative education, I think, I suggest. That is spirit. Okay? Before telling about the spirit factors, I think you are already sleepy because it's time after lunch. So I'd like to show you a movie, Interstellar, played in 2014. Did you see the movie? Okay. So let's watch this movie. And I'd like to tell you the basic plot of movie. The story is a father left Earth to go traveling out in space to save humankind and Earth. While traveling in space, he fell into a black hole and was caught up in a completely different space and time. This scene is, even though he is in a different space-time, the father, trying to send a message to his daughter on Earth. Do you think this message can be sent to her on Earth in different dimensions? Okay. Common sense tells us it cannot. It is impossible. Okay?
To save the world.
Please remember this scene. Okay?
All of
We
this.
will watch
One little girl's better
later again.
every moment. It's infinitely complex. They have access.
Okay, let's continue to introduce spirit factors, okay, to improve spiritual education, qualitative education. I will introduce several factors from now on. The first is challenge. Without challenge, we cannot proceed to subsequent next steps. Okay? I'm sorry, I'm a little surprised while I surveyed the data. There are so many outstanding scholars, Vietnamese scholars in the world. Okay? And I'm very proud of. There are some professors, my friend. Okay, I showed some professors are now working throughout the world. They feel so happy with UN and any other, or all professors may be very happy. But I think they went abroad and had overcome many difficulties and hardships. At last, they got a success. Okay? So, I believe one of the common features of their success is challenge. Okay? Without challenge, we cannot proceed to next steps. I recommend you report Akita International University in Japan has operated the global exchange program. As the result, the employment rate of the university AIU graduates has been at the top for 7 straight years in Japan. Wonderful, great. And 100% of all graduating students have secured employments for 4 years straight. And I'm very surprised. I read the books, NTTU pamphlets. The employment rate was 95%. It's so great. Okay? And the AIU has been chosen as the top 1 university in Japan. Okay? Usually we think Tokyo University is first, but Tokyo University is ranked second. So I recommend you refer this university. So I suggest strongly to give students to go to study abroad for 1 year. If not, at least 1 semester before graduation. Okay? Are there here students? Do you agree? You like no students, only professors. You don't need to go to abroad. Okay? Next is cooperation. Can be include sacrifice and contribution. Korea has ranked top class in the PISA assessment. You know PISA, Program for International Student Assessment, top class. This is mathematics rank. The blue line is Korea, is top rank. And the other is developed country, you know, US, Germany, United Kingdom, France, and the red line is Israel. Okay? And this is science rank, and this is reading rank. Korea has top ranked all the part. Okay? But however, very, very shamefully, unfortunately, there are no Koreans who have won Nobel Prize at academic fields until now. But as you know, Jewish winners of the Nobel Prize accounts for 22% until 2016, and almost 40% in economics fields. So we think, okay, generally, Jewish students are so excellent, but it is not necessarily true. Do not work. In Israel, education emphasizes cooperation more than academic study. In a more complex society, we cannot improve only oneself. We have to cooperate with each other, with others. I recommend you second university, Handong University in Korea, has operated GEM, Global Engagement and Mobilization. Students must go abroad and contribute and sacrifice themselves for above 1 year, okay, before graduating. This university is very small, a new university, somewhat university, but very promising, rising university in Korea. Even though the QS rank is not so high, but very, very good university, I think, I believe. Next spirit factor is environment. Okay? In the age of the 4IL, society demands students who have abilities, such kind of creativity and critical thinking and problem-solving abilities. So, nature-friendly environments as well as nature make humans affluent and increase students' abilities more than new advances with ICT devices. So, I recommend making your campus nature-friendly, can give creativity. This is the library of Akita International University in Japan. Okay? So gorgeous, beautiful. Only by sitting there, I think, the knowledge can enter my brain automatically. Okay? I can study all day long there. I hope stay there all day. And if only one student stayed in the library of Akita University, the library do not close. Only one student. Open for 24 hours. It's great. Books make people come together. Okay? That increase the spiritual power of students. Okay? 4C, as you know, critical thinking, creativity, collaboration, communication, the abilities demanded, required for the future. So, therefore, English and writing and art and music, especially, I think, traditional music is very important. And sports, athletics, fusion education are very essential for the future. And philosophy, history also. And lifelong education and re-education also required for the aging society and coming the society of the rapidly changing technology society. The last spiritual factor is love and trust and faith. I'll show you the movie again. Okay? Do not sleep. Let's watch again. The message, okay, the Father sent was able to traverse the different space and time through the different dimensions. That is, the Father behind the bookshelf could signal his daughter, letting her know he is still alive. But this cannot be explained by physical and quantitative factors of my educational model. If another girl saws the message, the Hands of Clock movie, she might pass by thinking only that the clock has broken down without recognizing the true meaning. But the clock provided very, very important meaning for both her father and his daughter, Murphy. Murphy believed her father was still alive and would surely keep the promise to return to her in faith. In that situation, when she saw the Hands of Clock movie, the daughter, she recognized her father is still alive and trying to tell he is still alive. That can be possible because there are long and faithful relationship between father and his daughter in love and trust. That is, it can be understandable by adding the spiritual factors of my education model. Today's the present remarkable development of Korea, where Korea was so poor than Africa, every nation. But now became wonderful. Korea is 11th economic power, great power nation. But it is possible made by missionaries. They came to Korea. At that time, Korea was unknown and barren lands. They came without fearing a death, and sometimes their friends and family and children was died just after coming to Korea. They constructed schools and planted the root of education in Korea. This is the first modern university, Yonsei University. Now is top 5 in Korea. It was founded by 2 missionaries, Allen and Underwood. In such a bad environment, they constructed about 800 schools since 1885. And they taught Korean people with love. This is your women's university. It's top class in the world in women's university. Very wonderful campus. However, Koreans have forgotten their contributions and sacrifice and love, and only compete, rival each other to gain their goals and purpose, their own goals and purpose. This is the reason, I think, for the stagnation and decline of Korea, present Korea. We Koreans do not promote or teach love and trust any longer at school as well as at home. I suggest Vietnam is similar to Korea. Do you think Vietnam is similar to Korea? No. I think Vietnam is better than Korea in many ways. I show you. The first, Vietnam is 3 times greater than Korea in land area. In Vietnam's population is 2 times greater than Korea population. Vietnam has many resources, but we don't have. Furthermore, Korea is divided to north and south, as you know. But Vietnam is united, one nation. I very envy you. Vietnam has a long, deep history. Okay? And Vietnam means concede the education the most. As you know, late President of Vietnam, Ho Chi Minh, considers education is the most. I'd like to introduce the saying by Confucius. This is Korean. He said, plant crops for 1 year's prosperity and plant trees for 10 years prosperity. What is next? Please tell me. I think you know. Plant humans, educate children for 100 years. Means not only 100, 10,000, okay, forever. Years prosperity, forever. I'd like to wrap up my presentation. Vietnam should educate for becoming a better nation. Educate. Vietnam can improve more than Korea in the near future through the education. Do you believe this? Yes, I believe it. Thank you. That's all.
Thank you, Professor Wang, especially for your recommendation and wishes, good wishes for Vietnam and for Vietnamese education. So I think we should. Thầy Thành, mình vượt quá giờ rồi, giờ làm sao bây giờ? Hay là tí nữa hỏi? So Professor Stan Wood, he suggesting that we will maybe have one question for Professor Wang before we break for coffee, because we behind schedule now is more than only 3:25 minutes. So may I invite one question or comment from the floor from the participant, please? Mời Professor Tan, please.
Only one comment. I would like to the lesson. You gave us a lesson about education, and I think that it contains very deep thinking about education, and it is for me a very interesting and a very useful lesson, because I think that people dealing with education in Vietnam should think about the philosophy of education first, and the lecture of Professor Huang is really very useful for us. Yes, thank you very much.
Thank you. Thank you.
Thank you for your comments. So should we break for coffee right now? And could you come back by maybe by maybe. So may I ask Mr. Kim to make some announcement, please?
Thank you very much. Before we inject a dose of caffeine, let me show you something. We have posted on the presentation slide of all the professors who have presented today on the website of the conference. If you go to the link of the conference website, you will see on the presentation today. You can download it and use for your self use. Thank you very much. Outside the hall is some snack and drink. You can have some if you like. Thank you. If you go to the website university4mo.ntt.edu.vn/agenda.php, you're going to see the agenda and all the presentation of the professor of today.
innovation-oriented basic research. So we have to define what direction is important for my university. So we consider the tendency of the world, about the about the priority of the Vietnam, and the strength of the Vietnam National University. So by combining these 3 points, so we have already defined the 7 priority of the research in my university. That is, advanced material for the green growth and bioenergy, so about the food safety, about the climate change, and about the simulation, about the microstructure and smart integrated system. And I keep this part. So in particular nowadays, we start to setting up some of the center for the support the startup for the student and the young faculty member. So here, this is the Minister of Science and Technology of Vietnam. He come to Mr. Opening this center for the startup in my university, and we just bring up very big building for this. So we did that. We are in the starting point, but we already pay attention to the innovation activity in my university. Yeah. So I back for this smart university. It also. Yeah. Final slide. So I realize that I and also Professor President of the University of Nguyễn Tân Thanh also already have a talk with the Minister of Higher Education of Vietnam, and we talked with him about how to running the University 4.0 in Vietnam. So the minister told us that, okay, theoretical is very complicated, CPS also very complicated. So they asked me, so try to list all the category, character, indicator, what about the University 4.0? And then we try to make one software, one website, in order all the university can come there and doing their benchmark. For example, I will make the link for the category of the University of 200 of QS, and you enter your parameter, and you can see that, oh, this parameter you are already 200 of top of QS, and for the other parameter is low, so you have to do the investment for that parameter. Yeah. So by this way, I would like to end my talk here. So I would like to say that my approach is we try to understand about the nature of the University of 4.0, and then we try to make application, the software, the website, in order that whole the University of Vietnam can be applied and do benchmark for their university. So thank you very much for your attention. Yeah.
Thank you very much, Professor. The idea of innovation-driven smart university is very interesting. I think in this region, we have sort of a bit of conflict between original research and applications. Our governments always required applications that could contribute, to contribute to the country. When researchers would like to publish original research, so we have to balance this, and this innovation-driven approach is perhaps a good answer. We still have time for questions. Welcome, sir.
Yeah, thank you for your nice presentation. Can you say a few words about how difficult it is to start a company in Vietnam? So suppose one of your students has a brilliant idea, comes out of an entrepreneurial university and now wants to start its own business. How difficult is that?
we have more difficult than that, because first, for the industry of Vietnam, very few factory of Vietnam, the industry of Vietnam, try to contact and push a question for the university how to do the research and the technology transfer. So as why very difficult to develop the research in the university. That's first one. The second one is the achievement of the research and technology in the University of Vietnam is very, very low. Yeah? Because many people hurry to do the application. So as why they do not pay attention to do the very, very high quality research. They can searching in the website, something like that, to do the application. So the application is very, very weak. So the impact to the social society is very, very weak. And then if we do nothing, the attitude of university is still very, very high. But okay, I understand. And if we do some application very well, very low level, so the attitude of university is down. And now your question is about the startup of the student and so on. Yeah, I say that when nowadays we start to organize some competition for the innovation idea of the student, and we make a selection. What is good? So some company will do the investment, or the other one. So I from myself from vice president, so I can find also some funding to do the investment for the innovation idea of my student. This story, yeah? The story of this one. Yeah?
Okay, thank you. Any more questions? Please.
Yes, thank you. I'm Guan from Malaysia. Thank you for your presentation, which is very informative about Vietnam moving towards education 4.0. As I can see it, the university VNU, Vietnam National University, is moving towards becoming an entrepreneurial university for Vietnam. Do you foresee that funding from the government will be decreasing, because as you go forward towards becoming an entrepreneurial university, I would think that your university will be generating more and more income for yourself, and subsequently you will be depending less on the government funding. Am I right on commenting on this? That's my question.
Yeah.
Is the government planning to reduce your funding, because as you are becoming a business university, you probably can generate more money for yourself?
In this case, we would like to say that at the moment, Vietnam are not in the situation that you have mentioned, because nowadays the government try to increasing the funding for the research and education. But the problem from my university is how we can create a good research program. Research design is very, very important. But you can design one, the topic is very, very low level and so on. We cannot pass the examination, and we cannot get the money from the government. So the biggest problem for the Vietnam now is that. So as why, in my case, I have setting up some key laboratory with the model of the co-director. One director is Vietnamese, and the other one, I invite one very famous professor from Korea, from Japan, something like that, and the international director. They do not pay attention for the administration and so on, but they can only function in the creating, design, the research program and so on. So by this way, we can have very good research program, and then we can apply for the government, and then we can gain money from the government. So by that's the way. Yeah.
Yes, please.
Professor Duc, I would like to ask one question. You show in the table that Nanyang University has 5,000 researchers. Okay, the Singapore University. Yes, here. The next one. The next slide.
National University of Singapore.
Okay, but the next slide, please. The next slide.
Next slide.
Yes, here.
It's a publication.
It's number of application.
This, in 1995, they wrote only this. We are here.
Okay.
When you were young, all the Vietnam had only 20 publications.
Yes.
But now they increasing.
But comparing with the Singapore, you have a very small, very small.
This because of the culture of the publication. So nobody is seeing that.
My question is, what is the strategy of Vietnamese government to enlarge the number?
Vietnam Vietnam have already established the the NAFOSTET, which means that funding for the basic research, and they only counting if you make application for the 2 ISI publication, so you can get this money. But you make the application for the 3 or 5 publication, so they will get higher money and so on. So by this way, the number of the ISI publication of Vietnam now increasing very, very fast. Yeah, but we have the other problem: quality of the international publication. Very high number, but very low number of citation. So that's why we are going to organize some meeting, try to solve this problem. So at the beginning, number, and now we have to say about the quality of the publication.
May I ask one more question? You mentioned about the incubation center that the university provide to students and staff. Yeah. Please add a little bit on the service that you provide. Because some students are engineers and technically trained.
Yeah.
They may not have entrepreneurship. What kind of support that you provide to them, please?
Yeah. I am in charge in this activity, and my first priority is how to setting up one funding for the startup of my university. Okay, so by this way, I will ask my faculty member come to contact with the industry to gain some money, the support from the industry, and we also come to the Ministry of Science and Technology to ask them support some money for this funding. So I think that start with funding and with the competition of the innovation idea. Yeah. So we can get we can choose the the optimum idea to make investment, and I hope that by this way you can step by step supporting the development of the startup in my university. Yeah.
Okay. So I think we have listened to very innovative talk from Professor Nguyen Vũ Đức. So please show our appreciation. Thank you. Thank you. Our next speaker is from Spain, Professor Manuel Nunes from Universidad Complutense de Madrid, Spain. Professor Nunes holds a doctorate degree in mathematics, computer science obtained in 1996, and a master degree in economics obtained in 2002. He is a professor in Department of Computer System and Programming. of the Universidad Complutense de Madrid, Spain. He is also a visiting professor at the School of Information System, Computing and Mathematics of Brunel University in the UK. Currently, Professor Nunes is mainly working in the area of formal methods for testing complex systems. He is also working on the use of formal methods in user modeling with an emphasis on collective intelligence. He has been teaching for almost 25 years. He is a member of the IEEE SMC Technical Committee on Computational Collective Intelligence and a member of the Board of Directors of the Taros Summer School on Software Testing. Okay. Professor Nunes has published extensively and has served in more than 120 program committees of international conference. Ladies and gentlemen, please welcome Professor Manuel Nunes.
Thank you. Thank you. So first of all, good afternoon. It's very difficult to be the last speaker of a session, so I'm going to do my best that you don't sleep, or if you're already sleeping, I will lower my voice. So first of all, I would like to thank the organizers of the conference for having me here. It's really a pleasure, and it's really, really interesting. So here I am. I'm going to talk about where we are at my university, Universidad Complutense de Madrid, what we did so far, and what we can do in the future. So I hope that is useful. So first of all, I would like to start with a disclaimer. So what I'm going to say is what I think, not what my university thinks. It's the first time in a talk that I use a disclaimer, but usually I give scientific talks where probably I did the wrong theorems, but at least it's my own responsibility. But here, what I'm going to say is what I think. So it's not that I'm going to say lies or something, but still, some of the claims might not be very politically correct. So I'm going to refer that as on my own. So I'm going to structure the talk in two parts. So the first part of the talk will be what I said in the title. I will talk about UCM 4.0. And then I would like to finish my presentation with a reflection, if you want, on how it's going to affect the job market, but especially in the case of the university, this new, wrongly called probably revolution, better call it evolution, that we are going through. So first I would like to present my university. I will give you some notes. Then I will mention the main problems. I will just concentrate in three things that I think are the most important problems that we have in our university to implement the 4.0 approach. And I will go through what we already did, and then I will finish with what we can do in the future. And in the second part of the talk, I will give you a personal view about how the job market, the current jobs that we have in the university can change, can suffer, can become redundant, etc. So first part. So our university was founded in 1499 in Alcalá de Henares. You can see Alcalá de Henares is not Madrid, but hey, we took the university. We steal from the original place. So Alcalá de Henares is the city where Cervantes was born. Cervantes is the writer of our most famous book, Don Quixote, probably you know it. And then we were moving to Madrid in the 19th century. Madrid is probably famous for this club. Do you know what is that? Very good. Still, we have a better team in Madrid. So, Atletico de Madrid. Yeah, I know we lost the last two finals against the champions, against Real Madrid, but
life is tough. But yeah, we have 2 teams in Madrid. So, like most medieval studies in the beginning, our university concentrated in just 4 degrees: arts, liberal arts, law, mainly with a theological approach, theology, and medicine. So our university has been home to most of our Nobel Prizes. We have only 8 Nobel Prizes in Spain, not many, but 7 of them were somehow involved with our university. 3 of them were professors there. In particular, both Nobel Prizes in medicine were professors in my university, and 4 of them were students. 1 of them had nothing to do, but 1 out of 8 is not so bad. So, some notes, and I would like to mention these numbers because they will make sense afterwards with what I want to say. So we have 77,000 students, and we are decreasing a little bit, not much, but you can see 10 years ago we were 88. When I was a student, it was a baby boom. It was probably more than 100,000 students in my university. It was a lot of people. So we have almost 6,000 lecturers, also decreasing during the last years, probably due to the crisis, because when positions where somebody was going to retirement, the state wouldn't allow us to bring the position again back. So it was a small reduction in the number of lecturers, but it's more important in the number of students. Probably the reduction in the number of students is not related to the crisis, just related to the age pyramid, but it's notorious. So our university is decreasing the size, but still is very big. But it's not only big in the number of students, in the number of lecturers, but shouldn't be a problem. If you have 1 million students in the law school, then probably you are easier to manage than if you have such a big structure. We have 26 schools. We don't have everything, but almost, so I'm just naming the schools according to the number of students. So law school is massive, it's really big. So journalism is big, education is big, economics is medium-sized, philosophy, political science, medicine, then we have math, physics, chemistry, arts. So we have then, later on, we have computer science. Computer science is very new to my university, and it's like a discontinuity, because it's the only engineering studies that we have. Well, now you know everything is called engineering. We have mathematical engineering, chemistry engineering, I don't know, philosophy engineering, but real engineering is computer science, and it's something very, very new. It's 25 years old. So it's really the only engineering studies that we have. Other than engineering architecture, we have everything. You name it, we have it. So we have 184 departments. We are going through our policy of reducing the number of departments, what makes sense. And in addition to that, because the medicine school is very, very big, we cooperate with clinics and hospitals. So this is the thing. We have many schools, we have many departments. We also teach a lot of different stuff. We have 71 bachelor degrees, 12 dual bachelor degrees. This is a very interesting idea, at least I like, but I was commenting this with colleagues and they were looking at me very surprised, like, what is that? Why would you like to have a dual degree? I said, yeah, because you would like to study 2 degrees, you do it at the same time, and you don't need to pass twice algebra and calculus or introduction to programming, so you just pass one. So we have several examples that they are complementing each other. For instance, we have a double degree and dual degree in mathematics and computer science, law and business administration, math and economics, etc. We have 156 master degrees, there's also some, and we have 57 doctorate degrees. So really a long variety. I said that my university is big, and I always thought that my university was big, and I was not proud. I think it's too big. But then I was checking, and is it that big? Not really. I mean, I was Googling, and according to Google, there is a university in Delhi with more than 4 million students. So we are nothing. In Bangladesh, more than 2 million. Turkey, almost 2 million, and I mean, you go on. So Vietnam, small universities, because it's good. It's easier to manage. And, well, okay, we are not that big compared to the rest of the world, but are we big compared to Spain? Not even that. The biggest university is this one, but this is a distance university, so that's why we have many students enrolled in this university. But other than that, yes, after this, we are the biggest university in Spain. So what's my point if we are not that big? The point is that peculiarities of my university has nothing to do, absolutely nothing to do with the size, it has to do with the heterogeneity. We are a very heterogeneous university, and it's really difficult to do something that fits them all. So, and I think this is the main cause of the problems to implement University 4.0. So, obviously, some of these problems might not appear in your university, but if you are similar to us, then you will face similar problems. Lecturers. Many lecturers do not use new technologies. Starting with myself, I think Professor Fossen said today that in mathematics, they still use blackboard and chalk. Yeah, I teach discrete mathematics, and yeah, I confess, I do it. I have good reasons to do it, and I'm going to tell you why I use, I'm teaching several courses, it's the only one that I teach with blackboard and chalk. And okay, imagine discrete mathematics to first year students of computer science. Computer science students, what they have in mind is that they want to write code so that there will be something moving on the screen very fast and very nice, or this is what they really want to do. They don't really want to learn math. What for? So I'm teaching discrete mathematics. I'm a funny guy, and I make jokes, but still, I want to keep attention. How do I keep attention if I give them slides? It's not going to happen. So at least I force them to copy. Something will come into their brains, hopefully. I know it's a very bad example, but yeah, when you're teaching mathematics in computer science, it works for me. So that's why I do it. But it's true. I teach other courses, and I have slides for all of them. Remember that I said that humanities are very important in my university, a big majority. But we have something else, and it's also related to what you said. When you were giving the talk, I was saying, I'm going to repeat this again. The average age in my university is high, very high. So around 25% of the lecturers are older than 60. 60% of the lecturers are older than 50. And it's not only age, I understand. I mean, if you are in computer science, you are used to use computers from when there were computers. In the beginning, one computer for the whole faculty, then couple of computers. But if you are not that young, let's say not that young, and you are not used to have computers, then it's very difficult that a guy comes and tells you, hey, you have to prepare slides, you have to use Moodle for your courses, or you have to prepare a mock. It's not going to happen. It's shocking in these statistics is if we concentrate on the number of professors, what is this category? So around 11% of the total lecturers are professors. So when I was computing, I have to run the numbers twice. 97% of them are older than 50. So I belong to this 3%. 3% younger than 50, 2 years to go, and it's really, really, I mean, there are 18 guys out of more than 600 that are less than 50, and I can tell you, out of these 18, at least 6 are in the computer science school, so we are really located in the same building. So changes, you want changes. Even worse, not only we are old and we work in humanities, we are civil servants, permanent civil servants. I mean, if you look at this, almost half of the lecturers in my university are permanent civil servants. And in these 53% that are not permanent civil servants, a big proportion are permanent. Not civil servants, they have a permanent contract. So let's put it together. So humanities, old people, we are tenure permanent civil servants. Doesn't look very good. I mean, it will be very, 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 very difficult that we implement changes. Because what for? Again, it can be even worse. Because now we look at this, our students. Yeah, our students. They are young, they use phones. They use phones better and faster than me, of course. It's only a couple of, I wouldn't say a couple of years, a couple of months that I took this thing that I see in my students. When you look at something and you want to write down, I look for a ball pen and a paper. They take a picture. It may sound stupid, but it's something that is, I mean, the first thing when I have to write something, I look for a ball pen. I don't look for the phone, but they will do it like this. And I'm getting used, not completely, but it's something that is, they are used. They were, as you said, they were born with a phone in the hand. Yeah, but this doesn't imply that they use new technologies. This doesn't imply that they can use Word or Excel. Let me tell you a story. So I was teaching in the economics school 10 years ago, something like that, and we have a course in Introduction to Informatics. Initially, we were teaching how to program, how to write small programs in Pascal. But it was very difficult. They didn't pass, so we decided to change the course. And when I was teaching, we were teaching them how to use Word and Excel. Not computer science, but hey, still. So I'm going through the computers, and I see one student. She's typing something in Word, and she's using the capital letters, and she will use she will lock the caps lock. She will press one click and unlock. Then again, so clicking cap lock, and like, excuse me, what are you doing? And she's like very, very much offended. I said, I have to write a capital letter. I said, yeah, but you have the other one, the one below, you just press for one letter. She didn't know. Obviously, she never used a typewriter, what is okay. We are old-fashioned, I can type with 8 fingers. Not this two for so, yeah, so she didn't know that there were two ways of making capital letters. One that it will be just pressing one time, and one keep it pressed. So it was really, I was really shocked. And then I took a keyboard and I was explaining to everybody, hey, if you want to just press one, you don't need to do the locking. So this shows that we cannot expect our students in general to know about computers and stuff like that. But this is sad. So after this situation, that it doesn't look very good, I must confess. Are we still doing something to modernize our university? We are doing things. So this is what I would like to go now through. So things that we have already done. So I'm going to split in the 3 parts: teaching, research, and administration. In teaching, we are enforcing the wide use of a virtual campus, this Moodle courses. Enforcing, promoting, asking, please, but we are on the way. So in this case, lecturers, if you are not used to these Moodle courses, they publish their material for the courses, and there you can give grades, you can make announcements about the courses. So the students can access the material, they are ubiquitous, and yeah, they have a versatile communication channel, what is always good. the university provides courses for both online and classroom, brick and mortar, to improve the students' knowledge of basic computer tools. And in addition to that, we offer many online degrees, mainly at the master level, or I would say only at the master level, not at the bachelor level. So we are doing stuff. Concerning the administration, I would like to be more positive, but yeah, you know, administration, paperwork. Bureaucracy is a French war, but we are very close to France, so probably we are not that bad. We are, I mean, bureaucracy in France is really horrible, but we are just horrible, yeah, but same thing. Electronic resources are slowly, very slowly, painfully slowly replacing paper. We can perform some routine procedures via the institutional website, so we can ask for certificates, we can upload the grades of the students, we can apply for positions in our university. These things you can do online, but not much more than that. So students can also perform some of the procedures online. They can assess the grades, they can apply for enrollment in new courses. These things they can do. They can communicate with the administration of the university online, but still, painfully slowly, lot of paper. For instance, when I grade my students, I can do it online. I will give the marks there, but then I have to print the marks and I have to sign. I said, no. In Spain, we have the digital signature. I mean, when I pay I can pay taxes online. And when I pay taxes online, I just need to give with the web page, you identify, blah, 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 and there's a digital signature. Why we cannot use the same thing in the university? Why do I still have to print the paper and sign? So, 21st century university with 19th century technology. It's not even 20th century. There were computers in the 20th century, most of it. Research. Yeah, it's getting better. So we can do some interactions with the university by online. Research groups are public, and you can update information about the research group mainly through your own web page, but they also have some institutional web pages. Principal investigators can do some tasks to help managing of funds. Till, I don't know, what was this, 5-6 years ago, I couldn't access the funds that I have. If I wanted to have a list of the expenses that I have done to a certain project, I have to go to a central service and say, hey, can I get a printout? Now at least I can access these things. Still, when I apply when I make a payment order, I have to sign in paper, but at least we are getting better. And when we have to apply for a project, for a grant, then at least the university is doing this online, but this is good. So you might be thinking, everything that you said is familiar, so is this that new? And yeah, it's new to me. Yeah, now, when we think about things that we take for granted now, they were not always there. I mean, I still remember the first time that I was sitting beside a guy in a seminar. It was in Dagstoel, yeah, many years ago. And the guy was accessing the internet with his computer without cables. And I was looking like, what are you doing? Yeah, and he has a laptop and very bulky thing plugged to the laptop. This was, what, 16 years ago, 15 years ago? So not 200 years ago. I mean, this Wi-Fi, like now, this was not there always. I mean, when I entered the university in end of '92, I was an assistant teacher. I have an email, but I couldn't write anybody. Nobody has an email address, so I could only write colleagues. I mean, nobody has an email address. Nobody had internet at home, so it was quite useless outside academia. In academia, it was very useful, but outside academia, email. I mean, you couldn't send an email to your mom. Hey, mom, I'm fine. This didn't work. So these changes are not that that old. So when was the first time that you were able to grade your students online? If you think it's probably not even 10 years, it's probably not even 5. So when was the first time that you were using Moodle? What, 6, 7 years, 8? When was the first time that you could get a teaching certificate? Well, I tell you, in my case, it's not so many years ago. So when was the first time that you could paperless apply for a grant? Okay, in all honesty, I can't do that, not yet. But it could be good, but we are not there. So these things that you might think that are many years ago, and actually they are not, is because probably we are using a wrong word. And this is something that we know in economists usually don't talk about the Industrial Revolution. It's a nice term, but it was not a revolution. It was an evolution. Think about the first Industrial Revolution. So if you want to give a date, what is very nice, you think about the Vata steam engine, 1783. But it was not like one day you wake up and say, hey, here we are, Industrial Revolution. It was something more progressive, it took longer. So probably started with the first steam engines in the beginning of the 18th century and finished around 1820s. In the 1820s, probably because they were already starting the second Industrial Revolution. So if you think about something that takes more than 100 years, would you call this a revolution? So it's an evolution process. And why do we say that the first Industrial Revolution ended in the 1820s? Probably because it's the beginning of David Ricardo's papers on division of labor, on specialization of countries. So if you think of the second Industrial Revolution, yeah, we think, okay, Ford assembly line, but probably started much, much before. If we want to give a date, probably in the 1870s, 1860s, with the development of the railway, of the electricity, and finish around the beginning of the First World War. So again, a shorter revolution, but not a revolution, not something that takes 50 years to develop. So my point is, we don't feel that the changes are that new because it's not a cut, it's not a break, it's taking, progressive, evolving a long time. The same we can say for the third Industrial Revolution, fourth, fifth, I don't know which one we are. Now we are in fourth. Okay. Well, fifth, sixth, it's probably the same. But it's always taking shorter. Okay, so the third Industrial Revolution is 69 till what? 1980s, 12 years or 15 years. But still, it's taking time, not one day, not from one day to the other. So, what we can do in the future in my university. So, despite all the problems that I was mentioning, we are still working on that. And at this point, I would like to thank, because I also was looking for material, and I wanted to know what, are we doing something? Do we have a plan? And I was contacting the Vice Chancellor, and he was very nice, and he was helping me with telling me what we are doing, at least from the innovation point of view. So it's very nice, and I would like to thank for his help. So, briefly mention the main intuition lines that we are doing, and mention more ambitious work that we could do in the future. So in teaching, we are starting a specific program to develop MOOCs, both in Spanish platforms and in international platforms. So we are promoting the universal use of the virtual campus, this developing of Moodle courses. I said before that we are getting there. We want to get more than there. I mean, probably not 100% of the courses, but as many as possible. So we are promoting innovative techniques and the using new technologies in teaching. And one thing for the globalization is we are promoting the creation of degrees in English. This is controversy. Why would you go to study in Spain in English when you can go to the UK or you can go to the USA? Yeah, but we are very popular with Erasmus students, so it's good that when they come, they can take some courses in English, at least in the beginning, so that they get used to the language. And also is a way of attracting other students. So we are promoting the courses in English. So to expand the market, if you want to call it. In Spain, we always traditionally have a big market with South America. Students will come because they speak the same language, and we would like to expand to grow this thing to other markets. So administration, we are starting a master plan to promote e-administration, again, as much as possible. The idea is that most formalities and most exchanges of information can be done via internet. This is interesting. The Vice Chancellor was mentioning that we are in the process of developing an application to generate a more effective communication with the students. Don't know the details, but I thought it was interesting to mention. And we are developing an integrated system to include all the institutional data. Of course, now the governing bodies of the university have access to all the data, but it is really dispersed. So the idea is to put them together so that when they have to take decisions, it is easier for them. It makes a lot of sense. So they want to integrate data into a common platform. Research. It could be good. The idea will be to include formalities related to management in the e-administration program, getting there. We are building a very big, because everybody has cluster of a very, very big computer cluster for data-intensive experiments. Take into account that, computer science is small, but we have a very big medicine school, and some of them doing research in medicine, some of them doing research in biology. They need a lot of computation power, so the idea is to centralize information there, and we can communicate. This is a very interesting initiative that my university is putting in practice. It's the second year this year. I like it very much. It's not much money, because there is not much money anyway, but it's the promotion of research projects, of groups in the university, but you need 3 research groups in 3 different departments. So it really, if you want this money, either for your CV or because you want some spare money to buy a couple of machines, you need to get in contact with people from other departments, from other faculties, and you need to have a common research project. Of course, you cannot expect that you are going to prove that P is not equal to MP or something like that, but it's good that you collaborate with different projects. For instance, one person in my group is running a project and is coordinated with a group in mathematics and a group in medicine, and our group in computer science. So it's very good. It's very good that at least people talk to each other. So I really like this idea of putting together people with different backgrounds and different research interests. So for the future, and this is my own creation, what I think we should try to do. Okay. We should try to go in serious games from research to teaching. We have some research group working on serious games, and probably we can move them. We can apply them to teaching. Lifelong learning. We really could be there. We could be there for companies when they want to learn something new, cutting-edge technologies. We could be there to form them. We could be there to teach them. It's something that we don't do now. I mean, we have our degrees, bachelor's degrees, we have our master degrees, but master degrees sometimes are just like a continuation of the bachelor degrees, and we should be focusing, or we should be trying to get this niche of the market. This is a dream, I know, but paperless management, I will be so happy. And ways of communicating students, lecturers, and supporting staff through new channels. This will be something that we should pursue as much as possible. This, with 100% of this one, I will be happy. I can remove the other 3, but paperless, it will be something. So, let me go to the second part of my talk. I am on time. Very good. It's always good to be in time. So, this is really worrying. I mean, university in industry 4.0 is really worrying a lot of actors. This was when I started to prepare this talk. It was very interesting that this is our report that they prepared for the President of the United States. Look at the date, December 2016, 1 month before he went home. So on the role of artificial intelligence in the automation and the economy. So the executive summary was mentioning that, yeah, AI capabilities will enable automation, but the way this is going to impact in unemployment and inequality is something that it is still to know. There will be unemployment, and unemployment brings inequality. During this crisis, the Gini coefficient has deteriorated in many countries. In Spain, has really increased a lot. So it's really inequalities are increasing, and there will be more with this. So what measures they can take to minimize this or to reduce this? So they identify 3 strategies, and I'm going to mention the one that is more related to us. Educate and train Americans for jobs of the future. So they already know, okay, there's going to be unemployment, so let's teach them something that they can do in the future, not what they can do now. You may say, yeah, United States has nothing to do with us. Okay, this is a little bit closer. Asian in Transformation is a report of the International Labour Organization in July 2016. And the conclusions are also not very good concerning the job market. Almost 60% of the jobs might be automatized, and this will have a lot of impact, mainly in women and workers with low education, workers that are having lower wages. So this is going to produce inequality. Conclusions of the report, something similar with a different wording, similar to what we saw before in a completely different context. A report to the President of the United States, a report by the International Labour Organization for Asian countries. Government and education and training providers need to actively anticipate for automation impacts. We could be there. We are universities. We should be there. We should do something. So you might be wondering, but how does this affect us? Yeah, we cannot expect that this is not going to affect us, our jobs. Probably we are too old to see this, at least this part. Over there, you will be more affected with that. But something is going to happen. I found this is a website where you say what is your job, and they give you the probability of your job being redundant. So related to university, if you are an archivist in education, then the probability of being automated is 75%. It's not good. If you are a librarian, it's 65%. When was the last time that you went to a library with paper? And not very often. Well, probably I go once a year because I have a couple of paper books, and every year they do the counting, so they have to check that you didn't eat the book, and that's it. I go once a year to the library. So, and what if you're a bookkeeper? Geez, it looks very bad. This is 98%. Yeah, if you're a college professor, it's only 3.2. So why should we worry? We are not none of them. So, yeah, we mathematicians, we are also happy. It's unlikely that we will be automatized. Not that we do something very important for the future of the world, but hey, we do difficult stuff. No big deal. Still, we are university lecturers, and the probability of our job to disappear is low. Are you sure it's that low? No. So let me just give you why I'm a little bit more pessimistic. So think how interactive you are with your students. Okay, don't think. Because human beings are not very critical with ourselves, so think about other lecturers, not about yourself, but in other departments. So have in mind, I know these guys in the department, so are they doing something very different from reading a book? I mean, if they have slides, some of them are just reading the slides. If they have a blackboard and a chalk, they are just copying their own notes that are yellow for the years that they were passing. So, can they be replaced by automatic readers with some basic capabilities to answer simple questions? Yeah, looks very likely, right? So, this is not going to happen to us. It's to the other lecturers, not to us. We are very good and we communicate with other students. But think about the other ones are probably being unlucky. So wrapping up, it is very likely that the staff currently working in the university will be redundant. Librarians, bookkeepers. So all these guys, I mean, these jobs are going to disappear, or almost disappear. It is also likely that some, if not many, lecturers will be replaced by intelligent robots. I'm thinking in robots like that, not like that. So this kind of robots. No, don't be scared. We will have mocks. We'll have serious games. We'll have new approaches that we don't know even yet. So with this situation that it looks more or less like Terminator, so can we do something? So yeah, we should prepare likely redundant administrative staff to train for new jobs. This is more a desire than a reality. Remember, I don't know, but half of them will be permanent civil servants. So, like Professor Fossen said, they will say, what? We should prepare likely redundant lecturers, not ourselves, are very clever, and but the other ones to move from classroom to alternatives. So, specific proposal. Lecturers know about the specific topics. They know how to prepare material for courses. I mean, I can give notes and I can say, hey, you have to take this, put more emphasis on this, put more emphasis on that. What we are very bad is in preparing funny material, entertaining material, videos. I don't know anybody, not a professional video editor, who can make a video more than 20 seconds without being boring. Very boring. Think about this wedding video where you are watching their people passing by. When they are made by a professional guy, they are very boring. When they are doing by your brother-in-law, they are horrible. So we are not video editors. We are not good for making contents. These guys, that they will be redundant, they might prepare to do video editing. It cannot be that tough. I'm not saying, I mean, not Francis Ford Coppola or Steven Spielberg, but something good they could be trained to do. So this could be a way of putting together all these people that are likely to be redundant in the near future to do something that they could be going towards these new approaches. So, conclusions. It's easier to do changes when you have small universities, young lecturers, and with technical studies. My university is a big university with with old lecturers, and where humanities are a majority. So, still we have taken some measures. We have an extensive use of the virtual campus. We are starting with internationalization. We are promoting e-administration. I have a master plan to take more measures in the near future. The implementation of University 4.0 will produce a shift in the job market. If we don't see it, then we are not looking at the problem. And we should take measures to transform redundant jobs into new jobs. So that's all I wanted to say, almost on time, 2 minutes more than, according to this thing, is 42 minutes, my presentation. So thank you very much. If you have questions, I'm happy to answer.
Thank you very much. 12 years ago, I went to Alcala, and there was a big university, very big.
Yeah, there is a new university now.
Is it your university?
No.
No. Not that one.
Okay, it was like this. So Alcalá de Henares was the original university. Then the university in the 19th century moved to Madrid. Then there was no university in Alcalá. And then in the 1970s, 1980s, University of Alcalá was founded.
I see.
Of course, they will say that, and actually they are partially right, that they are the inheritors of the old university, but they have a 400 years gap in the middle.
I see. Your mainly talk about challenge in change, handling change. Okay, I think I'm one of the older people in my university, perhaps the oldest one, and I welcome change. But you know, we have no resistance to change, but we need support. I think we need support, and some university provide support for this change. Like, for example, how to produce video materials and teaching materials. May I ask first, sorry, please add a little bit more on the support that university provide to these changes. Okay.
Thank you. Thank you for the answer. Yeah, thank you for the question. Essentially this is what I said in my last slide. If we will have support, but not only older people or anybody. I mean, if you are 25 years old and you are first assistant teacher, it would be good that somebody is helping you to develop contents. Yeah, we need support. But do we have support? Not really. So if we are the only ones, the ones who have to prepare contents, it is easier for somebody with a technical background to prepare contents, digital contents, than for somebody with a working, I don't know, in archaeology or in biblical studies. So it will be very difficult for them. So this, yeah, but of course, if the university will support, it will be good, great.
Agree. Okay, please, sir.
Thank you for your entertaining talk. It's very reassuring to see that we have very similar problems, although we are only half the size of UCM.
And we didn't talk about it.
And we didn't talk about it, yeah. I wonder whether old universities like yours or mine have a similar problem like big companies. Like, I think of companies like IBM or Siemens in Germany. Compared to startups, disruptors, are younger universities who are only 20, 25 years old, are they able to do better than us? Are they able to change faster than us? Are they able to avoid the mistakes that we might have made in the past? What do you think?
I'm not sure. I will say, if, for instance, in Madrid, we have a university on technical studies. It's just technical studies. It's everything engineering and architecture. So they are more homogeneous. But new universities are also expanding across humanities, law, medicine, computer science, so they will face similar problems.
Probably just repeat the mistakes that have been made 100 times already.
Yeah, because when they were created, I don't think it will be the new university. Only if they are. I think the problem is not big, it's not old, it's heterogeneous, homogeneous. I think this is the problem for implementing something at the whole scale.
Yeah.
Yes, please.
Thank you for your talk. Can you come back to your last slide, please? Yes, here. You say that a great part of your university is the medicine. This is not a good argument to know development university 4.0. Do you agree with me? Because with medicine, you have to use new technology. It's a challenge.
Yes.
Right? But why you do not use?
No. What I'm saying is that humanities is a big part, and medicine also is a big part. I didn't say that medicine is part of the problem. I said that I wanted to point out that it's not only humanities in my university. But still, once said this, medical. Can you stop recording now? Yeah, you know, they are. Sometimes my supervisor, my PhD supervisor, he had an expression. It was very good. When he wanted to refer to somebody who was, you know, like arrogant or something like that, he will call it the God's boss. So yeah, sometimes when you talk to medical doctors, yeah, they are like God's boss, and yeah, I'm not sure you can convince them how to manage new things. I mean, if they feel like doing, they do it. For instance, I have a very good friend working in another university, but in medicine. And they have these simulators, but it was very funny, the expression, when she was using the word simulator. For me, computer science simulator is something completely different. But for them, it's a dummy. So where you will perform operation, surgery, stuff like that, but this is like a plastic thing and simulates the human body. So they are using new technologies, no question about it. But still, we are civil servants, permanent civil servants, complicate things.
Okay, any more questions? May I ask a little bit? Please add a bit more on the active learning activities in your university, please. Do you have such thing? Active learning, flip classroom?
It really depends on the lecturer. It really depends on the professor. And again, coming back to the first talk of the day, younger people will promote more interactive learning strategies. The students will have to do more things outside the classroom, but it's not enforced. It's not a common strategy to promote active learning as we understand it.
Yeah. To my experience, one of our problems in my university and in Thailand actually is that we are afraid of being replaced by our own self. You know what I mean? For active learning, you have to record your lectures. And instead of asking you to give lecture, they replay your videos.
Yeah.
And you no longer hide. And that video could go anywhere in YouTube, and nobody invite you for special lectures anymore. Do you have that problem?
Yeah, let me tell you at all. A joke is 30 years old, as you will see. So there is this professor, he's always teaching every year the same thing, every year teaching the same thing, and then he says, hey, why should I come here? Why I don't record my talk with a tape recorder, and I just press the tape recorder. So the guy will go 1 year and say, okay, here is the tape recorder, and there will be my lecture, so you come every year, he will replace the tape, and then the students will come there, and they will take notes, the same thing. Till one day, he comes, and there is nobody in the classroom, but there are tape recorders in all the tables. So, yeah. We can replace they can replace us by a video, and then they will replace the students by just pressing the button.
Okay, it seems like we don't have any more questions. So thank you very much, Professor Nunes.
Thank you.
So this session is closed, and let you announce.
So thank you very much for the ending of the section 3. Tomorrow the conference will begin at 8 a.m. And Mr. Thong will pick the keynote speaker and the chair at the Liberty Hotel at 7 a.m. Thank you very much. Okay, so due to tomorrow it's going to be early at 7 a.m. So I will make some adjustment. Going to be around 7:15, 7:30 a.m. in the morning tomorrow.